Hi everyone, welcome back to our YouTube channel Zero Analyst. Today we're going to solve 5 most asked SQL questions. Now if you have any upcoming interview, which could be a data analyst interview, which could be a data engineer interview, which could be a data scientist or business analyst interview, make sure to solve all these 5 problems because you're definitely going to get one of the questions from these 5 problems that I'm going to solve in this video. Let's first go ahead and see a few of the people who have shared their experience along with these questions which I got using LinkedIn. So just go to LinkedIn and you just need to type this, which is called data analyst recent interview questions and experience. You can type it and you will be getting a few of the people who have shared their recent SQL interview questions. Okay, so let's see this one, and there is no interview questions. Let's see this one, there is also no interview SQL questions, but few of the example which I have gone through where I have got few of the SQL interview questions. So this one, which is called KPMG data analyst interview experience, which is for 2 years. Let's see. So here you can see this is the question which is called display the name of employee who have a salary above the average salary in their department. So this is one of the questions which I have included in the 5 questions. So this one questions that I'm going to kind of solve in this video, and let's see the second questions that I'm going to solve. You can see one more example that is shared by some other person, and you can see he has also mentioned the same question which is called display the names of employee who have a salary above the average salary in their department. Okay, and here we have one more problem which is called identify the second highest salary in each department. This also you can include it, but I'm not going to kind of include this one because I've already solved in this in the past, but I'm going to basically solve something similar. Let's see some more problems which I have included, and I don't think here I have it, but let's go ahead and scroll through a few more, and you will see some more problems. Okay, not here. So here we have one more example. Here you can see here, if I just click on more, and we'll be getting one questions from here which is called write a SQL query to display the employee names along with their manager's name using a self join. Okay, so this is one of the questions that I have seen most of the time. It is being asked for 1 to 3 year experience role. So this is one of the questions which I have included, and some more questions I have included. So I'm just going to show you the question that we're going to solve in this video, which is the top 5 questions. So the first one, which says identify the employee who earn more than their managers. So we need to identify the employee who earn more than their managers. Okay, we are going to have an employees table. From the employees table, we need to identify the employee who earn more than their managers. The first questions. The second question, which is called return each employee along with their manager's name. So again, we need to return each employees along with their manager's name. The third question says second highest salary using a subquery. So we're going to get the second highest salary using a subquery. And this is the fourth question, which is called display the name of employee who have a salary above the average salary in their department. So these are the 4 questions which are being asked most of the time. This is the 5th questions which I have noticed few of the time it is being asked, and it's a very simple one, but it can be very complex. So here we're not going to write code, but I'm going to explain how you should basically answer these questions. So the question says, can we get the same task done using full join instead of left join? Let's say you need to get something done using left join, where you need to use left join. Okay, now can we get the same job done using full join? If yes, explain how. Also tell which join will get the job done faster. Is it a left join that is going to get the job faster, or it is a full join that is going to get the job done faster? So this is what you need to explain. And for these 4 questions, we are going to write code, and we're going to see how to kind of solve these 4 questions in real-time interview. So let's first go ahead and see the data set, and then I'm going to basically solve one by one each of these problems. Okay, so now you can get this data set from the video description. Just click the link, download the data set, and make sure to solve all this problem, because I can assure you that you're going to definitely get one of these questions from these 5 questions if you're giving any data analyst, data engineer, data scientist interview in the SQL interview basically part. Okay, so let's go ahead and see the data. So here we have the data. You can see we have employees table. I have created this data sets for you, which I'm going to include it. So I just need to run it, and you can see it has already created the table, and we have all the records. We have total 13 employees. Okay, now here you can see we have total 13 employees. We have employee ID, we have employee name, we have salary, department, and manager's ID. We do not have something called manager's name. Okay, now if you see the first question, it says identify the employee who earn more than their managers. Okay, now we need to identify the people who earn more than their managers. Now if you see this data, we do not have their manager's salary. Okay, now how will we get their manager's salary? Then we can compare if this employee is earning more than their managers. Okay, let's understand this with an example in Excel sheet where I have already created the table. So here you can see I have already created the table, and added all this data just to explain you this concept. So you can see this employee and this employee, they both are managers, and that's the reason they do not have a manager ID at the moment. Okay, now if you see this, which is called Olivia, and for Olivia the salary is 80,000 and the manager is 1. Okay, now 1 means what? 1 means this is the employee ID, right? At the end, this is the employee ID. So this employee ID belongs to what? This employee ID belongs to Sophia. So that means Sophia's salary is what? 150k, right? So here the salary is going to be 150k, right? So Olivia's manager's salary is 150k. Okay, so same way, if you see for this employee, which is called Eva, for Eva manager is still 1, and if you see the salary for manager is again going to be 150k, right? So here if you see Eva's salary is 160k, right? So that means this is the employee that we are looking for. We need those employee where their salary is more than their manager. So this employee manager is 1 and that manager's salary is 150k. This employee salary is 160k. Okay, so this is something what we are looking for. And this second manager, that is going to be, I think, Liam. And let's see if you have any other records. So this employee, if you see Lucas is reporting to employee 2, which is called the Liam, right? So this Liam ID is 2. So basically here we will be having Liam's salary, which is going to be Lucas manager's salary. That's going to be 140k. Okay, so 140k. But if you see Lucas salary, that is what? That is 145k, which is greater than that employee's manager, which is called this 2. So Liam's salary. So this is the employee that we're looking for. So 1 we will be getting this employee, 1 we will be getting this employee. Now what approach we are going to use to solve this problem, which I am going to explain in pgadmin 4. So let's get back to pgadmin 4 and let's see how we can solve this problem. Okay, so I'm just going to use a simple self join to solve this problem. Let's go to pgadmin 4 and let's write down this question here. And I'm just going to say question 1, and first let's see the table. So for that I would just go ahead and say select everything from, which is called employees is the table names. I have already created the table, so I can just run it. If you see here, we have the same table. So this is the data, you can see it here. What you need to do is that we need to kind of make a join with the same table itself. Okay, based on this manager ID from the first table, and the second table we are going to basically do a join based on this employee ID. So manager ID and employee ID, and then we are going to get basically that person's salary. Okay, so that is what we are going to do. So here if you see the example which I have shown in Excels, so here what we are going to do is that we are going to do a join between this manager ID, which is going to be based on this manager ID. We are going to do a join with one more table, which is going to be the same table, but we will be joining with this column, which is called employee ID. Okay, so for each of this manager ID, basically for each of this ID, we are going to get that employee's salary. So for one, the salary we are going to get, which is called 150k, right? 150k, here is going to be 140k. Okay, here is going to be 140k, 150k. Okay, here is going to be 140k. Okay, 140k. Why 140k? Because this ID that you see, it is 2. Okay, this ID that you see, it is 1. 1 means what? That belongs to this employee, which is called Sophia. Okay, so that means if we have a same one more table, we can simply do a join using this manager ID from the first table, employee ID from the second table, which is going to be inner join. So let's go ahead and do the join, and then we will be getting these answers. Okay, so here what I'm going to do is that I'm going to call first table, which is called employees, as E1. Okay, as E1, and I'm going to say join, which I'm doing an inner join because I need everything that exists in both the table. And I'm going to say employee again, but this time I'm going to say as E2. Okay, now what I'm going to do is that both the table has a common column, which is called manager ID in the first table and the employee ID in the second table. So I would just go ahead and say manager ID from the first table, which is called E1, and the second table, which is going to be my E2, and that's going to have a employee ID. Okay, so employee ID. Okay, so I'm doing the join based on the manager ID and the employee ID. If I run this query, I already have my solutions. You can see it here. So what I have now is basically for each of this manager ID, which is here, this employee manager ID 1, I'm doing a join with one more table, and with 1 means 1, which is called one manager ID, and I'm doing the join with the employee ID 1, that is the Sophia. So Sophia is the manager for this employee, which is called Olivia. Okay, and we have all this data for Sophia. So what you need to just find out this salary. Is this salary is kind of lesser than this employee salary, then we would be getting that data. So you can simply use a where condition here. You can say, hey, if this salary is greater than this salary, then we need those records. Okay, so what you can do is that here you can just add a where conditions, and you can just go ahead and say that the first table, which is called E1 dot salary must be greater than E2 dot salary, because E2 salary is the manager's salary. The data we are getting from the E2 table, that is the manager's salary, and the data we are getting from E1 table, that is the employee's salary. Okay, so here if you go through once again, you'd be able to understand that based on this manager ID, which is 1, we are getting a join with another table with the employee ID, because at the end this is the employee ID, right? So that means we are getting this salary here. This is how we are doing the join, and we are getting the salary. Now if I just run this query, I will have the solutions. Okay, I will only have those employee where their salary is greater than their manager's salary. So if you compare it here, you can see the salary is 160k and this salary is 145k, which is greater than their manager, because this person has a manager which is called Sophia, and the Sophia salary is 150k, and this person's manager is kind of Liam, that is 140k, and they have a salary which is greater than their managers. Now if you need a specific column, then you can just write it here, whatever the columns you are looking for. What I'm looking for, only maybe everything from this table 1, so I would just go and say E1 dot everything. Okay, so everything we am looking for from the table 1, I can just run this query. So I would only have everything from the table 1. Okay, so that means these are the employees who has a salary which is greater than their managers. Okay, so this was the problem number 1. We are going to solve the second questions as well. Now let's go ahead and see the second problems, which says return each employee along with their manager's name. Okay, now here this one is again the same approach we're going to use, but we are just going to get the manager's name instead of getting this salary and comparing with this second kind of a table salary. So let's go ahead and see how we can solve it. Okay, let's go to Excel and understand this concept. Now if you read it here, it says return each employees along with their manager's name. Okay, if you see our main table, we do not have the employee's manager's name, but we have something called employee manager ID. Okay, so if I give you this ID, which is going to be kind of 1, I can tell you, hey, can you tell me this person's name? So obviously this is the employee ID. You will basically check in the database and you are going to find out this name, which is called Sophia. Okay, so you're going to say for this employee, which is called Olivia, the manager name is called Sophia, right? So you're going to write it called Sophia. Okay, and if I just give you again, for this one you're going to call Sophia, for this one you're going to call Sophia, for this one the employee ID that you see kind of 2, right? So for this one the manager ID is 2, so you're going to kind of find it, which is called Liam, right? Because Liam is the managers for this. Okay, so Liam. Now what you're doing is that we are going to do the same self join. That means we have one more table. Let's assume that we have one more table. That table we're going to call it E2, and table we're going to call it E1, and we're going to do a join between this manager ID. Based on this manager ID, we are going to do join with another table with this employee ID when we're trying to find out their name. So we're going to find out Sophia and Liam. So for this is going to be kind of Sophia, and for this as well Sophia, for this as well Sophia, for this one we're going to find out called Liam, right? So this is how we are going to kind of get the data, and if we do an inner join, so all this data is going to be gone, because we will only get the data where we have this manager ID and the employee ID common in both the table. Okay, so this is how we're going to solve the problem. So that means what I can do is that we are going to use the previous record only. So this query we can use it here as well. So let's first get everything from both the table, and I don't need this salary column right now. Okay, if I just run this query, you will be getting the same results. For each employees, we have the manager ID. Based on this manager ID, we are joining with one more table, which is called employee table, and we are joining with manager ID and the employee ID. So everything remains same. Here we get this name. So I just need to return everything from the first table and this employee name. Okay, so what I'm going to do is that the employee name is what? At the end, this is the employee name only, but this is the managers for this Olivia, right? So here I'm going to select that, select E1 of everything, which is going to be E1 of star. Okay, and I'm going to select that E2 dot employee name. Okay, and I'm going to call it as manager name. Okay, at then it is the employee only, but as this is assigned to another employee, so this is going to be a managers. Okay, so here if you see, what we are getting is that we are getting for all this employee who have a manager ID, for their manager's ID we are doing a join with one more table with the employee ID, and we are getting that employee's name, and that is how we are getting for each of this employee their manager's name, which is basically employee name what we are getting, but we are calling it as a manager's name. So this is how we have solved the question number 2 using same approach, which is self join. Now let's go ahead and see our question number 3. So the question number 3 is a little different. It says second highest salary. Use a subquery to get the second highest salary. Okay, let's first see how we can get the second highest salary. Okay, Let's first clear everything here. And if you see here, let's see what are the approach we can use to get the second highest salary. So if you see here, we can order this data in descending by this column, which is called salary. And I guess the highest salary is going to be, which is called 160K. This is going to be the second highest salary in our database, right? So what you can do is that we need the second row. Okay, now there is a very simple approach. You can use it like order by, and you can use the offset, but here we need to use a subquery. So using subquery, we're going to get it. You can also use the window functions dense rank to kind of get the same job done, which is more accurately you can perform this same task. But in the interviewer, they have mentioned as a subquery. So here we're going to use a subquery to solve this problem. If you see here, it says second highest salary using a subquery. Okay, so let's write down the questions number 3 here, and we're going to say second highest salary, what we're looking for. Okay, now let's see how we can solve this using a subquery, using a very simple approach. Let's say from this salary, if I just ask for the max salary. Okay, so the max salary is going to be what? That's going to be, which is this one, which is called this one, 160K, right? So 160K, what you are going to return, right? That's the max salary. Now this is fine. And if I just ask you one more time, what is the max salary excluding this? So what is going to be your max salary this time? Second time, if we just ignore this, the second max salary is going to be this, right? Which is called 150K. So the second max salary is going to be 150K. So this is the approach what we're going to use. In a subquery, we're going to get the max salary, and we're going to get, hey, get the max salary where the salary is kind of less than this 160K. Okay, so this is the approach we are going to use to get this problem solved. So I'm going to say select first of all everything from this employee, which is called employees. Okay, let's say everything, and I would just only select the salary. So I would just go ahead and say select salary from this employee, which is called salary. And here if you see the max salary, that's going to be what? That's going to be a 160K, right? That we have seen. This is the max salary, 160K. So I can just go ahead and say here is that what I'm looking for is that max salary. Okay, max salary. Okay, and if I just now run it, I will be getting 160K. Okay, cool. Now I would just go ahead and say where, and I'm going to say salary is kind of less than. Okay, salary less than, and here if I just put 160K. Okay, 160K. So what is going to happen? What do you think what is going to happen? I'm just saying, hey, get the max salary from this employee table where this salary must be less than 160K. So I would just first show you the salary. Let me just comment it out, and let's say I just want to show you the salary, what usually happens. Okay, let's first comment it out. Let's first show the salary again. Okay, let's first run this table, and if you see right now we have all this salary. So the highest salary is going to be what? That is going to be, which is 160K. So now if I just go ahead and do a order by, just to show you here, I'm just going to say order by kind of salary descending, so that you see the highest salary first. Okay, so 160K is the highest salary, 150 is the second highest, this is the third highest, right? So what I'm saying is that I am just going to say, hey, get me everything from this employee table, but the salary must be less than 160K. So that means this is going to be my first record, this is going to be my second record. Okay, I can just put this order by after this where conditions. Okay, and here I would just go ahead and run this query just to show this to you. If you see right now 160K is excluded. Why we are saying here is that, hey, get me the salary from this table, which is called employees, all the salary, and I'm saying this salary must be less than 160K. We're just putting some value here, okay, which is 160K, because we know this 160K is the max salary. Okay, now we are getting all this. Okay, so here you can just simply go ahead and say maybe the limit 1, or we can just go ahead and say kind of whatever you want to say, right? We can just go ahead and say limit 1 if you just want one record, or you can just go ahead and say max salary. If you just say max salary, what do you mean? So max salary is going to be selecting one record with the highest kind of salary. So from this table, at the moment the highest is 150K, right? So if I just now go ahead and run it, I would have what? 150K, correct? So what I'm saying, instead of putting this 160K directly, how I got this 160K, right? So I got this 160K something like this. Select max of salary from employees. Okay, see, this is going to return what? I'm just saying select max salary from employees. Okay, so this returns what? 160K, correct? So I put it 160K earlier, and now I am just putting it in a complete query. Okay, so this is called a subquery. So using this subquery, I am going to get 160K, and then I am just executing this outer query. So that means I'm saying, hey, select me the max salary, but before it has a where condition, so it is going to only get the data, all the salary where this salary is less than this is, which is called this query, which is 160. Then it is going to return me the biggest salary, that's going to be 150K. That is how I am getting 150k here. So what usually happens, as soon as I execute this query, first SQL is going to check is there any subquery. Yes, we do have a subquery. SQL is going to complete that subquery, so it is going to return 160k here, and then SQL is going to complete the outer query. Then SQL is again going to execute this query, and then it is trying to kind of filter out the salary by excluding 160k, and then it is kind of returning max salary, which is going to be 150k, because 160k is already excluded. Okay, so this was the question number 3. Now let's go ahead and see the question number 4, and the question number 4 is again little different. We can solve this using two approach, but I'm just going to use a correlated subquery to solve this problem. You can also use a window functions to solve this problem as well. Okay, so let's go ahead and see the problem statement 4. It says display the name of employee who have a salary above the average salary in their department. Okay, now I would just go ahead and put this here, which is called question number 4. Okay, let's try to understand it again. It says display the name of employee who have a salary which is above the average salary in their department. Okay, we are looking for those employee who have a salary which is more than their department's average salary. Okay, let's understand this in Excel in a better example. So we have Excel here, and if you see, we have, I guess, 3 department. One is called this department 1, and department 1, department 2, and department 4. Okay, so we need to find out each department and their average salary. So department 1, 150k, and then we have kind of 80k, that's going to be 230k, and then we have, which is called 60k, so that is going to be 230 plus 160k. Okay, and we have I guess we only have this, and we have one more, which is I guess we only have this, so it's going to be 0, and it's going to be 9, it's going to be 4. Okay, so 490 what we have, and if we divide it by kind of 4, so it is going to be kind of 190 divided by 4, that's going to be somewhere around 22 point something, right? 22.5. So this is the average salary for department 1. Same way you can find out the department 2 and the department 4 average salary. Now what you need to return is that for each department, we need to return those employees who has salary which is greater than their department's average salary. Okay, so let's go ahead and see if we have any employee who have the salary which is greater than their department average salary. So obviously if you see this employee which is called Sophia, so Sophia is from department 1, and so Sophia's salary is more than kind of this, so Sophia what we're going to return. And we have one more employee which is called Eba. So for Eba as well, it is kind of 160k, which is greater than their department. So this is what we are going to return. Same way we need to find out in the department 2 what is the average salary. To find out the average salary, we need to plus 140k, then we need to plus 85, then we need to plus 145, 95, and 135. Okay, all this you need to sum and then divide 1 2 3 4 5. Okay, so you need to divide by 5. That's how you will be getting the average salary, and then you just need to compare it. Okay, so this is how for each department you need to get the average salary, then you are going to compare it, and then you're going to select the employee if that employee's salary is more than their department average salary. Now how do we solve this in SQL? Okay, so to solve it, first we're going to use a simple approach, it's called correlated subquery. So here I'm just going to select everything first of all from this table which is called employees, and I would just go ahead and say select everything from employees. So at the moment we have selected everything from employees. Okay, now to solve it, we are going to use a little different approach which is called correlated subquery. Okay, we are going to make a connections with the columns in the where conditions. Okay, so you may get a little confused, but you just need to go through this video 1 or 2 times, you would understand this. Okay, so here what I'm going to say is that let's say I want to first work with this employee. Okay, that's called Sophia, and the department ID is 1. So I'm going to say that, hey, for the department ID 1, let's try to find out the department ID's 1's average salary. So what I can do is that I can simply go ahead and say that average salary. Okay, get me the average salary of employee where the department ID equals 1. Okay, so that's going to be what? The average salary of department, which is called 120k. Okay, so this returns the department ID 1, which is called DID 1. Okay, and 120k is the average salary. Let me just write it down for example here. Okay, so that is the department ID 1 salary, which is the average salary. Let's check for the department ID 2. So that's going to be again 120k, and we will just run it, and it's still 120k. So DID 2, and the salary is 120k again. Okay, let's check for the next one, which is going to be select average salary for department ID 4. Okay, let's see what is the average salary. Here it is 78,750. Okay, so for DID 3 it's called 78. Let's write it down as a 78k. Okay, so these are the average salary for different department that we have at the moment. Okay, Now what we're going to do is that we would need to first select everything. Okay, so I am first going to select everything here just to show you. Let's select everything back again. Okay, now what we are doing is that let's first check for the employee ID 1. So let's say first we want to check if this employee ID 1 salary is more than that employee ID's department, which is 1, that department average salary. So here basically we need to call it that we are going to say salary of this employee, which is called the first employee, must be greater than, okay, must be greater than what? That employees department average salary. Now we know that this employees belongs from department 1, so we can simply run a one simple subquery that's going to return us the average salary of that, right? So you can just go and say salary from employees, okay, because this returns the average salary of entirely the company, but we need only for one department, so we would say where department, okay, ID equals 1. Okay, so this returns kind of the salary of one specific department, which is called the department 1, and that is 120k. Now if I just now run this query, okay, if I now run this query, it is going to do the job done rightly for only the people who are from department 1, okay, because the department 1 average salary is 120k, and we would be able to identify these employees, and we're going to select this employee because this employee has a salary which is more than their department average salary, that is more than 120k. Okay, now what about the people who are from department 4? So this employees which is from SAM, and that is not going to select it. Why? Because for this as well we are trying to check if this SAM salary is more than kind of 180k, which is not true, because if you see it here, SAM salary is only 85,000. Okay, but there is a possibility that SAM's department average salary is less, correct? So that means this approach is not going to be correct. So what you can do is that we will need to build a connections between each of the column from here with this subquery. That is the reason we call it correlated subquery. So what I'm going to do is that now I'm just going to do it in a different way. So I'm just going to call it as employee as E1. Okay, so I would be getting from E1, what I'm going to get is that E1 of everything, or I can just say that E1 of I need basically called employee name. Okay, what I need is that E1 of which is called the salary. Okay, and I guess I need only do 3 things, and I need one more which is called E1 of department. Okay, so I would just go ahead and say E1 of department. So I'm getting all these things from employee table which is called E1. Okay, I just named it called E1. Okay, so here I'm saying again E1 of salary, which I'm comparing, and I'm comparing with something. So here what I want, every time I check for any specific employees, here I just want to put that employees department average salary. Okay, now every record may have a different employees department ID. Okay, so every time we need to check that employees department ID, then only SQL is going to basically include that row based on this their department average salary, because we need to compare it in where conditions. Okay, so SQL usually checks row by row. So for each row it is going to kind of check the same average salary at the moment, which is department ID 1. Now how do I ensure when SQL is working for the when SQL is working for the first row, SQL take the department ID 1 and put it here. When SQL is working for the second row, take the department ID 2 and put it here. And this is how SQL check for every employee, check their own department's average salary, and that is how SQL select that row or it doesn't select it, right? So for that, what I can do is that I can just go ahead and automate it here. I'm just going to call this table as E2. Okay, and I would say that E2 dot salary. Okay, and I'm just going to say that where, okay, let me just put this where conditions in the second line, and let's put this in the second line as well. Okay, let's put this where condition in the second line. Here I'm just going to say I'm just checking E2 dot department. So I just have everything same as it is. Now I'm saying that hey, just forget about the outer query. Okay, here I'm saying hey, select me the average salary from the employee table, which is called E2. So I'm just saying E2 of average salary, and I'm saying hey, where the E2 department ID is this. Okay, now here I need every time to change it, right? Whenever SQL is working for the first row, SQL should put 1. When SQL is working for the second row, SQL should put 2. When SQL is working for maybe this 11th row, SQL should put 4. Okay, so further what I can do is that I can make a relationship here with this. Okay, I would just go ahead and put this here. Okay, so here as soon as I execute this query, SQL is going to first run this query. Okay, let's just run this query to show you. Now as soon as I run this query, SQL is going to first complete this subquery. Okay, because SQL first attempt to complete subquery. So SQL is going to select the average salary from an employee table, which is called E2, and but it has to go through a where condition. So for the where condition, it is going to get this department ID from the outside query, which is this, because SQL is working for the first row for the first time. Then the department ID is going to 1, and it is going to return the average salary for the department ID 1. Then it is going to check with this salary, and luckily it select this the employee, which is the first employee. Then basically SQL check for the second employee, which is called Liam, and then basically SQL select Liam as well, because Liam's salary is also which is greater than their department own salary. Then SQL check for Olivia, and Olivia's salary which is less than their department average salary, so SQL doesn't select it. Okay, so every time this ID get a chance, because we have created a relations with this. Okay, this is how it is kind of getting all this employee who have a salary which is greater than their kind of department average salary here. So if you see Alex, we have 110k and from the department 4, and we have Sam which is from department 4, because their department average salary is less compared to kind of the people who are from department 1 and 2. So this is how we have solved the question number 4. Now if you have a different approach to solve it, that is absolutely correct. You can use the window functions, and you can also solve this same problem. You just need to use the window functions average to get each employee's department salary here. Okay, let's now go ahead and see the question number 5, which is very easy and it can be very complex as well, the way how you explain. Let's see this question. It says, can we get the same task done using a full join instead of left join? Okay, so the answer is yes, we can get the same job done using a full join instead of left join. So what usually happens when you do a full join, you are going to get everything from both the table, but that means all the rows from both the table. If there's a match, that is great. If there's a no match, you are going to get the opposite table, the null. Okay, let's say we have a table here. Okay, so this is the table. This table has a kind of few rows. Okay, so we have 4 rows in the table 1, which is called T1. Okay, let's say we have one more table here, and that has kind of again maybe kind of 5 or 6 rows. Okay, so let's go ahead and put some rows here. Okay, let's say we have few columns here as well. Now let's say if you are kind of getting the same job done using a left join, so you're only going to get everything from this left table, and based on the match you're going to get this information from the right table. So let's say what you are going to get is that you're going to get everything from the left table, so you're going to get 4 rows. Okay, so you're going to get 1 rows, okay, and second rows, third rows, 4 rows. So every rows you're going to get from this table, and let's say it is matching with this, it is matching with this. Okay, and let's say this is matching with this, and this is not matching, still you're going to get this, but you're not going to get this 2 basically rows. Okay, why? Because they are not matching if you're doing a left join. Okay, so at the end what you're going to return is that we're going to return 4 rows. Okay, so this is what it is going to happen when you do a kind of left join. Okay, let's put some matching values here so that you don't get confused here. So let's say I'm just going to kind of put some matching values here. Let's say I have here called 1, here I have 2, here I have 3, here I have kind of 4. Okay, let's say this is a department ID, and we have a department ID here which is called ID, department ID, and we have 1, we have 2, we have kind of 3, and we have kind of maybe something which is maybe kind of which is not here. Okay, so right now we will be getting the join using left join. We're only going to get this 4 rows. Okay, this is fine. Okay, so if you're, let's say this is kind of 6, this is kind of 7. Okay, now if you do a full join, what is going to happen? In the full join you're going to get all the rows from both the tables. So let's say first you're going to get all this 4 row. Okay, then you're going to get kind of the remaining rows from here. So you have got 1, this one, you have got this one, you have got this one, you have got, you're going to get this which is automatically from this, right? So it's going to be kind of 1, 2, 3. Okay, and you're going to get 4. Then you're going to get, this is basically this one which is called 6 and 7 as well. So we're going to get a 6 here, you're going to get a 7. Okay, so in the full outer join basically you are getting everything from both table, and that is the reason full outer join is basically slower, right? Full join, that is the reason the full join is slower compared to the left join, which is faster, right? Because left join will only return the specific rows from the left table, and full join is going to return everything from both a table, and that is what it is going to kind of make it slower. Okay, so this is the answer to the question number 5. If you have any other approach, so do let me know in the comment box, guys. Thank you so much for watching the video till here, and if you have enjoyed this video, do make sure to hit the like button and to subscribe to my YouTube channel if you're new to this channel. I will see you in the next video. Till then, keep learning and stay consistent. Have a good one. Take care. Bye bye.